Well, hello there everybody, I'm Paul, and it's time to have a look at the skies of autumn, as we're into September, and it's all rapidly changing. Start off with the customary look at the sun. Well, it doesn't look like there's much change there. The sun is completely blank at this moment, but there have been sunspots, and it does seem to be livening up a bit. Now, when we last looked at this figure here, the number of percentage of days with no sunspots in 2020, that was 72%, and indeed the month before that it was 77%. So we see a definite downward trend going on there at 68%. There have been no sunspots for 9 days. This is updated as of the 31st of August when I'm recording this. But it does look as if things are changing on the sun slowly. We'll have a look just forward. This is the prediction for solar cycle 25, and I think it's pretty clear that we are now well into solar cycle 25. We're sort of coming out of this trough here at the deepest minimum in perhaps 100 years or more, that came out of solar cycle 24, but now we're into this upslope here. There are some sunspots happening, and this does make for some interesting possibilities regarding aurora. Indeed, there already have been some aurora sightings in this cycle. Let's just have a look at this. This is the Russell-McPherron effect. Now, it wasn't understood for a long time quite why this happens, but around the equinoxes, September, it's actually the 22nd this year, and March, the spring and autumn equinoxes, that time is very favourable for auroras, and it's just thought that actually having the Earth's axis vertical in relation to the sun means that the Earth's magnetic field is somehow better at drawing in the solar wind to create the auroras, where the solar particles interact with Earth's atmosphere at the poles. And that's certainly been happening a little bit. There's a picture from Christian Berg up in Norway, taken just at the very end of August. This is from space-weather.com, space-weather.com. Best website to go to for all this aurora stuff. Great place to start. And you can see that up in Norway there's been some pretty good interaction between the Earth's magnetic field and the solar wind. Now, just to elaborate a little bit on that solstice information, so this is from a website I find very useful called time-and-date.com. Hang on, it's not dash, that's only hyphenated because it's in the presentation. Time-and-date.com. There we go. And this gives you the sunrise, sunset, moonrise, moonset, all that sort of thing. I've got it on the sun information here. And at the beginning of September, this is all set for Belfast. At the beginning of the month, 1st of September, sunrise is 6:31, sunset is 2014, giving a day length of 13 hours 42. And astronomical twilight, when you can realistically go out observing, that's 22:31. And we'll do a little bit of that in a moment. However, you look how this changes during the month, and by the end of the month we're from 6:31 to 7:24 sunrise, and sunset comes in from 2014 down to 1901, which means the day length is down to 11:36. And the important one, your astronomical twilight, when you can get a decent enough dark sky to go observing, that's down from 22:31 to 21:01, an hour and a half difference during the course of September. That's really why I like September so much. It all changes quite quickly. Now, meteorologists will have you believe that the 1st of September is the start of autumn. Astronomers, we know much better, of course, and we know it's the 22nd. That is actually the point at which the sun crosses the equator from the northern hemisphere into the south, and it's 1431 this year. That's not stated there. However, because of the fact that the definition of sunrise and sunset includes the diameter of the sun, which is half a degree or so, it's a little bit offset from what you might think. So the day, when the day is 12 hours long, as close as it gets there, looks to be the 24th rather than the 22nd. It's a small discrepancy, but an important one. And likewise on the 24th, the sunrise is directly east, 90 degrees there, and the sunset is directly west at 270 degrees. So that's some facts and figures about the sunrise and sunset. So let's move on to have a look at the night sky. Now then, here we are. It's 22:30, the start of astronomical twilight on the 1st of September. So let's have a look first of all at the northern sky. We're looking north here, and we see not far away from directly north the bright star Capella. Now Capella is visible all the time, and it is actually quite close to its lowest at that point. Up the other side here we see the familiar outline of the Plough, or Big Dipper. I actually like the American name Big Dipper better because it looks like what it is to me, but that's just a personal preference thing. So you've got the 3 stars of the handle here, and then the 4 of the bucket there, and you take the 2 end ones, Dubhe and Merak, and you follow those upwards, sort of 5 times or so the distance of the space between them, and you will come to another bright star, which is by no means the brightest star in the sky, but it is second magnitude and therefore quite obvious, and that is Polaris, the pole star. And that's the star that when you see those photographs that go round and round and round the North Pole, that's the one in the middle that stays almost but not quite still. It's not exactly over the pole, but it's less than 3/4 of a degree away from the North Celestial Pole. So that's how you find north in the northern hemisphere. Let me tell you that finding south in the southern hemisphere is much harder because there isn't a bright star there. But they have a much better Milky Way than we do, I'm afraid. Okay, looking in that area now, if we wanted to sort of zoom in on this a bit, and the autumn is always a good time for looking at galaxies, and this is a good pair of galaxies we have here, Messier's 81 and 82, Bode's Galaxy and the Cigar Galaxy, and we find those by taking the 2 opposite corner stars of the Big Dipper here, Vector and Dubhe, and we draw a line between those 2, and then we go the same distance again, carrying on through, and that puts us in the right ballpark to find Messier's 81 and 82. Now we can zoom in on this, and you'll see that this is a very beautiful pair of galaxies. There we are, and that's M81, and M82 has a good sort of hydrogen alpha content there. If you've got a red sensitive camera, that will show up very well on it. And there's also various other galaxies around that area too, so good part of the sky to go looking for galaxies. The best galaxy, of course, is not very far away either. Let's go and find that. If we sort of zoom out here and head off towards the northeast, or indeed actually east at this point, in the early part of the night. This here is the Great Square of Pegasus, these 4 stars, and that's very, very conspicuous in the eastern sky. We have just got a little bit of Mars appearing there as well. Actually, we'll look at planets a bit later. What we do here is a bit of star hopping. We take, first of all, the top 2 stars of the Great Square of Pegasus, and we keep the distance between those 2 in our mind there, and then we go to the top left star here, Alpheratz, which is actually an Andromeda, and then we go that same distance again, having taken a slight right turn, and we end up at another bright star, Merak. Now we stop at Merak, and we take a sharp right turn and go just a short distance here, and that star there is Mu Andromeda. And then we go the same distance again, and you'll see a fuzzy patch here. That's how it appears to the eye. And that is the Andromeda Galaxy. If we go and have a closer look at this, there we go, we zoom in on the Andromeda Galaxy, you'll see the shape of it appearing there. This is Messier 31, the Great Andromeda Galaxy, and it's got 2 satellite galaxies. You can see M110 and M32. And what people don't really appreciate about the Andromeda Galaxy, it's not really all that bright. You can see it from a dark site, it's about 4th magnitude, but what you see is just as a fuzzy patch the bright core of it. You don't see with the naked eye or telescope even all this. You need a lot of light gathering to see this. A camera with a modest telescope will show it with long exposures and stacked up and so on, but what you don't get with the eye is how big this is. And let's just take the angle measure to it, right? If we go here, they are 3 degrees from end to end, including all the spiral arms and so on there. That's 6 moons wide. So that's pretty big. If that was much brighter, it would be an absolutely spectacular sight in the night sky. So there we are, that's the Andromeda Galaxy. Now then, looking towards the southern sky, I've still kept the date on the 1st of September and 10:30 in the evening. Looking directly south, we'll see we have two nice bright planets. Now they are unfortunately a bit low. This isn't the best time to be looking at these two planets. However, they still look quite good. Jupiter and Saturn, and they are getting slightly closer to each other. And that's important because in December, the 23rd of December, they will actually come very, very close together. Now, it will unfortunately be just after sunset, but it will be one of the closest planetary conjunctions you can see in a long time. They will appear to the naked eye as one star, and you'll need a telescope to separate the two. But that's where we're headed with Saturn and Jupiter here. Let's go into Jupiter and just have a look and see where we are with the moons. And this is the 1st of September, remember. So we have there two Galilean moons visible, and two behind Jupiter by the look of it. And no great red spot at that point. We do have, Io is in front of Jupiter, as is its shadow, so that's a good one to look for. 22:30 on the 1st of September. A shadow transit there, and I assume that Ganymede is behind. Yes, it is. Yeah, Ganymede is behind Jupiter at that point. We can run that forwards and just see how that goes in an hour or so. There we go. Yeah, Io becomes visible, and its shadow is still on Jupiter an hour later. And then coming into past midnight, the Great Red Spot is very visible there. The Great Red Spot, of course, a huge storm that would completely engulf the Earth and has been there for at least 300 years, and comes and goes a little bit, but shows no signs of actually going away. So that's Jupiter. Now then, still in the south and moving just 7 or 8 degrees to the east from Jupiter, we find Saturn, and let's just go and have a look at Saturn more closely, because we've still got plenty of rings visible on Saturn. Now that will change in the next few years as we get towards 2025. The ring plane flattens and will be almost edge on, but here we can see we've got Saturn with its rings. The shadow of Saturn on its rings is now becoming more pronounced as we move away from opposition, and we can see plenty of moons here. The most obvious one, the easiest one to see, is Titan, and it's actually sort of sitting almost above Saturn there, but a couple of others, Dione, Tethys, Rhea, they can be seen if you do sort of overexposed webcam shots, that kind of thing. Titan is bright enough at 8th magnitude that it'll show up on a photograph of Saturn quite easily. So that's Saturn. Now Mars is very interesting at this time. Not only is it getting bigger and brighter as it approaches opposition in October, but its motion through the sky is very, very interesting. Now what I've done here is I've set this up. I've set the date back to the 14th of August, and I've set the time on to 3:30 AM so that we can see this. And what I'm going to do is I'm going to track through the dates here into December, and I've got this set up so that we'll get a trail of where Mars has been in the sky. Normally you'd expect planets to sort of head on towards the east as time goes on, but that's not quite what happens with Mars here, because it gets into what we call retrograde motion, and that's as the Earth catches up and overtakes on the inside. So here we go. Here goes Mars. There we're coming to September now. There goes the moon, and coming through September we're now going back the other way. There's the moon again into October. We're into retrograde motion now, and then we come into the middle of November and it starts going back the way it was before, and then it sets. So there we are. That's the retrograde motion of Mars. Very, very interesting. Now then, let's have a look at Venus. I saw Venus the other morning, actually, about 4 o'clock, in the constellation Gemini, blazing away like a supernova. It really was very, very impressive. I've set the date here to the 14th of September and the time to 4:30 in the morning, and we can see at that point that Venus is a waxing gibbous phase. It's on its journey to the other side of the Sun. It's now 65% illuminated. So we see Venus very, very bright. Magnitude -4.2. and looking good. But actually, I've chosen this date particularly because this is a very interesting part of Venus's orbit. Because, let's zoom out a bit. And we will see, where are we? Here we go. We will see that Venus is in very close proximity to a nice thin crescent moon there. That moon is 14.3% illuminated, so a nice thin crescent. And right in between the two is the beehive cluster. Now let me just adjust the visibility of things here and take away that one, probably that one. There we go. And you can see there how Messier 44 fits beautifully right between that thin crescent moon and Venus there. So there we are, M44, Moon and Venus conjunction, 4 o'clock in the morning, 4:30, 14th of September. Now here's one other thing worth looking out for this time of year. What I've done here, I've moved the date along to the 21st of September for the reason that gets the moon out of the way. And also gone to 6 o'clock in the morning, which is a good time to see this particular spectacle. You can see the Zodiacal Light at this time of year. Now we've got Sirius and Orion coming up in the south here, looking quite prominent. But down here we've got Leo just in the east, and Venus points the way to this one. This cone of light here, different from the Milky Way, very different, but it merges into it, is the Zodiacal Light. And the Zodiacal Light is caused by dust in the inner solar system being illuminated by the sun. It's a very sort of faint glow, but if you see it from a good dark side, it can be quite obvious. I was very lucky a couple of years ago to see it from the Arizona desert in March, where of course it appears in the west after sunset. I saw planets Mercury and Venus set with the Zodiacal Light very clearly visible, like this eerie glow in the sky. My pictures weren't that great because I was travelling with a more sort of daylight orientated camera, but I got some. Good chance to see that anytime really from September and October, as long as there's not a bright moon in the sky and you're in a reasonably dark place, you can see it, and it's well worth a look. So that's the Zodiacal Light. Now then, while we're up this early in the morning, it's well worth having a look at Orion, which is much more prominent now than it was in August, and quite visible, quite high up in the southern sky, around about 6 o'clock in the morning, which is still darkness at this time as well. This is 21st of September, I'm on here, 6 o'clock. And of course the thing with Orion at the moment is Betelgeuse. Betelgeuse has for the last year or more been fluctuating quite a bit in brightness. It went very dim. Now looking here on Stellarium, let's say that they're quoting 0.45 magnitude for Betelgeuse. Well, at one stage it was probably even a little bit dimmer than Bellatrix, and Bellatrix is 1.6. In the normal course of events, Rigel here, magnitude 0.15, and Betelgeuse are pretty much the same. Actually, they're not that different in brightness at all. And remember, of course, that the designation of Betelgeuse is Alpha Orionis, which does rather suggest that at some stage it was brighter than Rigel, which is Beta Orionis. So, but now I saw Betelgeuse at the end of August, and I estimated its magnitude to be a little bit dimmer than normal. Quite obviously dimmer than Rigel, probably something like about 0.7 or so. So it does still seem to be fluctuating. Now, whether that means it's going to explode, yes, of course it is going to explode, but you know, this is the thing with stellar timescales, that any time in the next 100,000, a million years probably. So we'd be very, very lucky indeed to see it in our lifetime. Betelgeuse is far enough away that it exploding wouldn't actually do us any harm. It's about 600 light years away. Some say less, some say more. But it wouldn't sort of blow the atmosphere off Earth or anything like that. But it would be a bright star in the daytime sky of about -12 magnitude or so. if it blows, but that's a very, very unlikely thing to see, but someone's going to see it sometime. So that's Orion. Now then, as my hero Lieutenant Colombo says, just one more thing, and there's a whole bunch of ISS passes in September. Now they're coming 2 batches really. From the beginning of the month, you'll see passes in the morning sky. So this one, for example, here on the 2nd of September, magnitude -3.1, peaks at 5:17 a.m., 41 degrees up in the sky, and that continues down until about the 12th, and then we get into a whole bunch of evening passes starting from the 18th onwards, and some of those are really quite big and bright. 21st of September we have a -3.1 here that's 39 degrees high. That's not the absolute highest. This one probably 23rd of September, -3.4, that's 21, 26 in the evening. That's going to 50 degrees directly in the south. So that's about the best. There's a couple of 3.4s magnitude there. So right the way through to the 29th of September, some great passes of the ISS. So do look up and wave at the ISS, and remember there's I think there's 5 or 6 astronauts on it at the moment. It varies a bit between 3 and 6. And sometimes even more than that, but it's well worth seeing that very, very bright object. It takes about 5 minutes to go across the sky, and if you haven't seen it before, it really is quite spectacular. So that is everything I have to say. I want you to stay safe, keep looking up, and thank you very much for watching. Bye bye.